right, what allows you to do theoretically is measure the true impact of price on demand. Okay, so let's think about this. Something that is correlated with price, but not with choice. So if we think of one of these that might be occurring, what happened with like pipeline, give you a hint in Alabama, or south. What's happening right now with prices? Gas prices. They're expected to go up. Is that going to influence your decision on where you go for Thanksgiving? No. So gas prices might be something that's correlated with price, because the higher the gas prices, probably the more the airlines are charging. But you could argue that the gas price, in theory, probably doesn't influence too much the destinations that airline passengers choose. So the key thing is that a lot of work has been done within the econ literature to look at these instruments, and I'll review them in a bit. But the way the two-stage control function method works is it's really quite simple from the mathematical perspective. The trick is finding these instruments. So the way this works is at first you estimate a linear regression model. I'm estimating price as a function of everything I'm going to put into my discrete choice model. So that time of day, those marketing relationships, everything I want to do. And then I basically put in two instruments. 2 is like the magic number on these tests. If you can find 2, you're doing well. You can do 3 or 4, but life is much simpler if you can get 2. So after I estimate price as a function of all the variables I'm putting in my discrete choice model and my instruments, I then basically say the residual, the difference between the price and the predicted price. I then run my discrete choice model. Again, I put in the same variables I put into my first stage linear regression model, put in my price coefficient, and then the residual. What I can do then is I perform several statistical tests. The first one is I just look at the significance for that residual. I use a t-test. If it's significant, it says, yes, you have a price endogeneity issue. This is something you need to address in your model. Then how do we correct it is we end up running 2 discrete choice models. The first one we've already done. The second one I put one of the instruments in. Now what did I say about an instrument? It's something that has to be correlated with price, so it's influencing the first equation, but it doesn't influence choice, which is the second equation. So what am I hoping for? Am I hoping for this instrument to be significant or not significant in the discrete choice model? Not significant. So yeah, so what happens is when I set this up, I get to use the likelihood ratio test to compare the difference in log likelihoods. The test is if it's less than 3.84, the instruments are valid. Meaning again, it's there's no difference. There's basically no statistical difference between these two models. The instrument is doing its job. So practical things, for those of you venturing into instruments, I'm going to, if I may, add what I've learned, lessons learned as we've gone through this process. I'm going to show instruments for models that we developed. It took us about a year to find these instruments. It is a very challenging process. If you look at the literature, the key things you need to look for is everybody can come up with an instrument, but the magic word, are they valid? Did they pass all of the statistical tests? So many papers out there talk about instruments. I would say very few of them get to the point of finding them to be valid, meaning they pass these statistical tests. Okay, so which instruments? There are 4 classes of instruments that have been used in the literature. I'm just going to show them here briefly because I know you guys haven't seen them, just to show you that many exist and have been used. Cost shifting variables are used at aggregate level. There are things that impact the product's cost. Like I mentioned, the fuel cost, distance, whether you're a hub. Again, Hausman type are really looking at similar prices in other markets. So the idea being that if your cost structure from DC to San Francisco is probably similar to your cost structure from Miami to Seattle. Looking at similar markets, you probably have similar cost structures. So whatever is going on in the price structure in Miami to Seattle can be used as a proxy for what's going on in your other markets. Competition and market power, these are the ones I think the airlines feel most comfortable with because we're often thinking about competition. So competition can be like number of nonstop daily flights, number of seats in your market, which is a function then of the type of equipment you're putting in. Perfidel index is a measure that's used in econ as a measure of market concentration. Number of carriers, sometimes we see type of carrier if you have a low-cost carrier in the market. And non-price characteristics of other products, BLP, some of them have used it. This one we found to be a little bit more tricky, but it's things like percent of rival routes that offer direct flights. So it's somewhat similar to the competition structure, but you're looking at characteristics of other products. So many have been done with an econ on this. Our instruments, at the end of the day, we found are two instruments. One is the Hausman type, and one is the Stern type. So we found the cube of average price by carrier in similar markets, and the cube of the number of seats. So what's going on in similar markets, what's going on in terms of the capacity you're offering in that first business class cabin versus your low-cost coach cabin was important. There is no behavioral explanation I can give you for why it was the cube. Again, a lot of this just becomes the statistical modeling exercise. The intuition is really average price isn't affecting my choice, and number of seats is not affecting my choice. That's the behavioral intuition for why these instruments sort of work. Okay, so we mentioned before the problem we have is that the price coefficient tends to be positive. So one of the things we saw when we ran this is that before correction and after correction, notice my price coefficient is going more negative. That's good, right? That's what I expect. That's what I'm hoping for. And if you look at the value of time, before correction, I'm basically overestimating what's going on. Because again, the model's going to predict high prices, high demand, right? So a business traveler ahead of time, I would have predicted in the model, was willing to spend $126 to save an hour. After I control for price endogeneity, that's down to $83. Similar for leisure, I moved from 65 down to 44. I can also look at this in terms of price elasticities. Wow, leisure side. Look at what's going on there. What does it mean if I have a negative 0.89 versus a 1.26? So reviewing our elasticities, a measure below 1, negative 1. So let's say the measure of 0.89, recommendation is raise price. If I have a negative 1.26, recommendation is lower price, give more demand. If you're elastic or inelastic. So what we see is that, especially in the leisure markets, when we do this correction, or we correct for price endogeneity, many of the markets, meaning the short haul, long haul, we looked at all 10, would move from this inelastic recommendation to the elastic recommendation. We compared our results to other elasticities that were reported in the market. Again, it's going to vary as a function of the data source, market, what you're looking at. But our coefficients were coming out to be very reasonable compared to others that were reported in the literature. So once we did the correction, we were quite, again, happy with where they were sitting in the literature. Okay, other factors, just for completeness, what else did we find? Well, strong preference for nonstop itineraries, the negative 2.49. These directs are slightly preferred over connections. We typically see this. Larger aircraft preferred over smaller aircraft. So you got a wider, narrow body. You like that more than an RJ or prop. And then these marketing relationships, code shares are selected more often than online. This is basically, if I'm going to let people sell on my aircraft, I'm going to get more passengers. This is basically what it's kicking up. It's not really behavioral, it's more of a market exposure measure. And then with interline, again, those are more negative. Again, I as a passenger am taking a risk for everything. Those are much more onerous. Okay, for time of day, I realize this is a big chart, but we went through all of this effort to basically estimate these highly refined time of day curves. The scale on these are the same. So what I want to ask is, where do you see the red bump being the highest? So on the red curve, what day of week? Tuesday, also maybe Monday, Wednesday. And red is for outbound passengers. So the utility is highest on Monday, Tuesday, Wednesday for outbound passengers in the morning. Does that make sense?
Yeah.
Business travelers leaving for work, right? Okay, when do business travelers come home?
Friday.
Thursday, Friday. Most Thursday I'm consulting. When do I see the biggest bump on the return on the green, which is the return? Okay, Wednesday, Thursday. What do I notice about, we'll look at Saturday, Sunday. What do I notice about Saturday and Sunday, especially Sunday?
The same.
Yeah, it's the same. There really isn't a time of day preference on this one-time westbound short town. It's probably leisure, I have hotels, someone will leave in the morning, evening. There isn't a very strong time of day preference as I do when I probably have these business leisure travel segments to begin. One of the questions I often get that we got in review is, okay, well, time of day preferences, we understand that those may matter in the short haul markets, like this one time zone westbound, but what if you're trying to schedule a flight to China from the US? Is the time of day preference really important? So one of the things we can look at, or why I wanted to show this 3 time zone westbound, is we do see, and I've estimated these internationally, we do see the pattern continue. What do you notice about the time of day preference? The strength or the height of the lines on the right versus the left? The time of day preference stronger or weaker on this basically side? It's weaker. So why is that? Well, it's like we said before. I might take the red-eye flight. I'm losing or gaining 3 hours. By the time you're traveling to California, your day is shot. I mean, like, I hate to say this, but your day is basically shot if you decide you're going to take a trip to California. Versus if you guys are planning a trip up to DC, which is an hour-and-a-half flight away, wow, I can leave at 6 o'clock in the morning, get here at 7:30, 8 o'clock, museums open at 10, I'm ready to go. Skip TRB, we're doing museums, right? So, before the whole day starts, right? You get a full day by getting up early. So you have more choices, I would argue, on what happens in your day for these shorter distances. You have more options as a business traveler on these shorter flights, which tends to make the time of day more pronounced for these. Short haul flights, time of day, I would argue, especially if they're the non-stops, tend to be much more critical looking at the time of day preference and scheduling. Okay, extensions beyond M&L. Those of you that have had Pat Mokhtarian's courses, or mine, know that the M&L model has some pretty nasty assumptions associated with it, meaning that if I add a new flight into a market, I'm assuming it competes equally or proportionally to the market shares of all the other itineraries. So basically I'm saying if I put in a Delta flight at 8 a.m., it's going to compete similarly with other Delta flights, other Southwest flights, and it doesn't depend on when in the day those other flights are. So these competition patterns are something that we normally like to try to incorporate in our discrete choice models. We have various structures we can do. This model, which is a 2-level nested logit model, says, well, I think my non-stops are going to compete more with the non-stops than they are with the connecting. I can go through, estimate a model. This mu LOS is basically a measure of how strong that competition is. Okay, so I'm able to get this or extract these competition patterns from the data. I can do a 2-level M&L model. Maybe it's really the non-stops in the morning, compete most with the non-stops in the morning, then the next level of competition could be, and with other flights in the morning, right? So depending on how I structure these, I can basically look at what dimension of competition exists. Is it level of service, non-stop connecting? Is it time of day? We can also think carrier might be important. Delta flights can be with Delta flights. And so airlines are really set up to use these advanced discrete choice models. The other one we talked about is that, well, you know, we see time of day is important on the utility side. Maybe it's also important on the competition side. So one of the other types of discrete choice models is called the OGEM model, the Ordered Generalized Extreme Value. What this does is it basically says, okay, look, I have a flight departing at 10 a.m. On a one step, it says, I'm going to compete most with flights that depart in that 10 a.m. period. A little bit more competition between the flights that depart from 9 to 10. A little bit more from the ones that compete from 10 to 11. And then all the rest are the same outside that area. So this one step is basically, you think 10 a.m., I compete most with 10, a little bit more with 9 and 11, then everything else is the same. A 2-step is the same idea, except for that 10 is basically most with 10, next level with 9 and 11, and you go out 2 steps, 8 and 12, and then everybody else. So again, you can go through and see how many steps you need, look at the correlation patterns, and extract, if you will, sort of the optimal competition pattern from the data. So one of the things I was curious about is that Greg Holdren was a fellow colleague of mine that worked at United Airlines back when I was getting my dissertation. And Greg estimated a lot of these complicated models based on 1999 data. Let's think about it. 1999 data. Ours is 2013. What has changed from 99 to 2013 in the airline industry? September 11? I don't know, maybe internet, right? Internet, iPhone, mergers, acquisitions, been a lot of different changes. So these are those log sum coefficients. One of the things I was shocked at is how well our models are matching what Greg found back in 99. The behavioral patterns, these competition patterns, are not changing much. The one that's changed the most is for carrier. Basically, we're not seeing a strong carrier competition on our side. Numbers next to 1 are being less competitions, less than 1 being more. Greg saw more, Greg Coleman saw more in his models, but then again, remember, he also had like 20 carriers in his data set back in '99. We have had a lot of consolidation happen in the industry, so not as many opportunities, I would argue, to look at that pattern. The level of service was very similar. Greg had a number greater than 1, we were just below 1. And this time of day is by far the one that's least, or furthest from 1, so this means where we're seeing the most competition. So this time of day is really popping up to be, let's say, the most dominant form of competition that we're seeing in the itineraries. And again, 0.78 to 0.81 is practically statistically insignificant between the two data sets. We then looked at other 3-level NL models. Again, very consistent with what Coldren said, are found. The carrier by time of day, or I'm sorry, time of day on top, carrier on the bottom, is the structure that ended up being important in both for the 2-level NL. And then Greg didn't have as much data as we had. So for our OGEV models, what we found is that our 3 allocation hourly model is working better than any of the other ones. So that OGEV structure, which just incorporates time of day, basically has the best statistical fit. So time of day seems to be very important, and we're looking at this. So I had a couple other points I wanted to mention that, when I think about students and where dissertations can go and research, we never quite know when we get into it. We started this saying we wanted to look at the price endogeneity problem. We wanted to do this using a big data set. One of the things we had to do is we had to look at different software to estimate it. Biogeme is a freeware Michelle Laurie has used. A lot of researchers have used that. Stata is a commercial software package as well that many use. And one of the things you find is that some of the software you might have to program in your own models. Like Biogeme doesn't do the 3-level NL. You have to write customized code. Stata doesn't do these OGEV models. Larch is a software program we wrote ourselves. And we wrote it to basically take advantage of a lot of the underlying data structure associated with itinerary choice. So while that's a separate paper and separate talk, the thing I want to talk about is, okay, so we're at 3-level NL, Larch is at 2.3 seconds, Stata is at 21. We get to the OGEV, and we're running into a lot of difficulty. Once we start getting into these complicated models, you think about, oh my God, am I ever going to graduate, right? That's really what this is saying, to estimate one model. So Biogeme is at 3 days, 24 hours. Anybody want to guess what we were able to get our computational times down with Larch? So 4 days, different software, it's just a test case. Throw out a number.
4 minutes.
4 minutes? 2.14 seconds. So we spent a year basically writing a software program to be able to estimate it. This is freeware software. We'll be posting examples online using a data set ARC11 release, but it's out there. If you want to work on these itinerary choice models, big data sets, Larch is something that Jeff Newman helped write to basically make that possible. Okay, the current work we're working on with Zero and Chen is that one of the things that's bothered me is I go back to that, there's 160 itineraries to get from DC to San Francisco. How many of us, when we go to the website and pull something for Travelocity, look at all 153 choices we're making our decision? Is that what we do? No, what do we do instead? Talk me through what you think about when you go and you purchase an airline ticket.
Price.
Say that again?
Figures.
Fares?
Figures. So I'm already interested in a particular time of day or a particular
Okay.
X month price.
So maybe you're looking at certain criteria, connections, you sort them out, so you maybe eliminate some that have it. Okay, so one of the things that we did is that there's Amazon Mechanical Turk is this new sort of platform for business schools are all over this because you have little workers, well I should say little, you have workers that basically you can pay to conduct surveys or do other tasks. A lot of this is I need to record labels, or enter this text in. So it's this huge workforce that will conduct tasks at what to me appears to be the most amazing bottom cost price you can do. So for instance, on Amazon Mechanical Turk, we designed a 20-minute survey and are paying 25 cents. And within the first week of launching that, we did a test, we had like 300 respondents within 3 hours. Just again. So we wanted to basically look and see if the Amazon Mechanical Turk workers were giving similar preferences to those we would get from traditional surveys. And I also wanted to, so part of it then is I took a traditional survey from Resource Systems Group, which had used recruitment from their Airline's frequent flyer database. So I have a data set that's probably as close to airline frequent flyers that I can get. I mimicked one of those questions, but then what we did is we basically created this interactive screen. And so what we were interested in is if individuals are using filters or how are they sorting. So we're interested to see how the online search and purchase basically influences which itinerary you're going to select for going forward. So we're live with this now. It's been very interesting hearing the responses from the AMT workers. A lot of them, the most recent problem we have is you only get paid once to do the survey, and a lot of people can't remember if they've done the survey because they're doing so many tasks. So we need to, program up front to let them know if they've done the survey, so they don't have to retake it. So just a lot of interesting things popping up. But our contribution is, we basically came up with first estimates by